Hello everyone, I'm Kalaivani from SNS College of Pharmacy and Health Sciences. I'm working as an assistant professor. Welcome back to today's Pharmacognosy session. In this video, we'll be exploring one of the most fascinating and widely distributed groups of plant constituents, the flavonoids. Flavonoids are everywhere in your fruits, vegetables, tea, and even the medicines you take. They do not only give plant their vibrant colors but also offer some powerful health benefits. So let's dive deep into and understand their chemistry, classification, sources, and pharmacological importance. So coming to the definition, to begin with, flavonoids are a large group of polyphenolic compounds that occur naturally in plants. They have a common C6 carbon skeleton, which means two aromatic rings are connected by a 3 carbon bridge forming a heterocyclic ring. You might remember seeing yellow or orange pigments in flowers that are often because of flavonoids. Coming to the chemical structure. Now let's look at their chemical structure. All flavonoids share a basic skeleton of two benzene rings A and B, linked through a heterocyclic pyrrole ring called the C ring. Depending on the substitution pattern, that is, where the hydroxyl, methoxyl, or sugar groups attach, we get different types of flavonoids. This small change in structure actually leads to big differences in their color, solubility, and biological activity. Alright, next is classification. Flavonoids are classified based on the degree of oxidation and saturation of the C ring. Let's go through some of the major classes quickly. Flavonols like apigenin and luteolin are found in parsley and celery. Flavonols such as quercetin and camphorol abundant in onions. Anti-inflammatories, for example, naringenin and hesperidium, occur in citrus fruits. Flavonols or catechins are present in green tea and cocoa, and anthocyanidins are responsible for the red, blue, and purple colors in berries. Isoflavones like genistein are mainly found in soybeans, and finally chalcones, which are open chain flavonoids, are seen in plants like licorice and hops. So, as you can see, flavonoids are truly a diverse family with a wide occurrence in the plant kingdom. Now, where do we find flavonoids? Practically everywhere. They are abundant in fruits like apples, grapes, and berries, vegetables like onions and kale, beverages like tea and wine, and of course in herbal plants like Osimum santum, tulsi, Glycyrrhiza glabra, licorice, and Camellia sinensis tea. So next time you sip your green tea, remember you are taking in a dose of a flavonoids. Let's now talk a bit about how plants make these compounds. Flavonoids are synthesized via the pyrrolopropanide pathway, which begins with the amino acid phenylalanine through a series of enzyme reactions mainly involving phenylalanine ammonia lyase, chalcone synthase, and chalcone isomerase. The plant forms various flavonoid subclasses. It's quite amazing how plants use this pathway to produce such a large variety of beneficial molecules. From a pharmacognostic point of view, let's call the organoleptic characters. Flavonoids are usually yellow to orange in color, sometimes red or blue. They often have a bitter or astringent taste, and they are soluble in alcohol, but not only slightly in cold water. When isolated, they may appear as a crystalline or amorphous solids. Alright, now let's look at some simple chemicals used in the lab to identify flavonoids. In the Shinoda test, if you add magnesium ribbon and concentrated HCl to the alcoholic extract, a pink or red color appears, confirming flavonoids. In the alkaline reagent test, addition of sodium hydroxide gives a yellow color that disappears when you add acid. The lead acetate test gives a yellow precipitate, and the ferric chloride test gives a green or black color. These are classic pharmacognostic tests to confirm the presence of flavonoids in plant extracts. Pharmacological activities. Now, this is the most interesting part. Their pharmacological importance. Flavonoids exhibit a wide range of activities. They are strong antioxidants, protecting our cells from free radicals. They show anti-inflammatory, anti-diabetic, cardioprotective, and even anti-cancer activities. Some also act as a neuroprotective and hepatoprotective agents. For example, quercetin has shown potential in reducing oxidative stress, and naringenin improves glucose metabolism. making them highly valuable in managing conditions like type 2 diabetes. In the pharmaceutical field, flavonoids are used in nutraceuticals, cosmetic formulations, and herbal medicines. You'll find them in anti-aging creams, antioxidant supplements, and liver tonics. They are also being explored in novel drug delivery systems to enhance bioavailability. From an analytical point of view, flavonoids can be identified using UV visible spectroscopy, where they typically absorb between 250 to 400 nanometer. For quantification and detailed analysis, HPLC, TLC, and LS-MS techniques are widely used. Generally, flavonoids are safe when consumed as a part of the diet. However, excessive intake or concentrated supplements might interfere with some enzymes or hormones, especially with isoflavones. So, moderation is always the key. Finally, let's look at what's happening in current research. Scientists are now working on nanoformulation techniques like using exosomes or nanoparticles to increase flavonoid absorption and stability. AI based models are also helping identify new flavonoid targets for diseases such as type 2 diabetes and neurodegenerative disorders. So, the research in flavonoids is not just historical, it's a rapidly evolving field with modern relevance. To sum up, flavonoids are one of nature's most beautiful gifts, colorful, therapeutic, and versatile. From your morning cup of tea to advanced drug formulations, they play a vital role in maintaining health and preventing disease. So, next time you see a bright colored fruit or flower, remember it's more than just beauty, it's chemistry and pharmacology in action. Thank you for listening, and if you found this video helpful, don't forget to like, share, and subscribe for more pharmacognosy lectures. Thank you.